Okay, so moving on to part D now, we're asked to implement segment which takes a positive integer n, such as 3456, and a two-argument function grouped. It returns a linked list S containing linked lists of digits, such as a linked list of 3, 4, then a linked list of 5, 6. Together, the elements of S contain all digits of n in order. Two adjacent digits, a and b, with a to the left of b, appear in the same element of S if grouped of a and b returns a true value. Okay, wow, this is a pretty complicated problem, so let's just go over one of the doc tests to make sure that we really understand what's going on. So essentially, we're being passed in some kind of positive number, and what we really want to care about is if two adjacent, if two pairs of digits that are adjacent to each other satisfy the grouped function. So basically, we're checking if like all of these pairs satisfy grouped, and if they are, they're put in the same linked list. If not, they're separated into different linked lists. So if we have the number, like this big number right here, and our group by condition is if a equals b, well, since 3 doesn't equal 2, 3 is going to be separate from 2. But then you have this chain of 3 3s that are all equal to each other, so they're all put in the same linked list. And then you have these 2 4s that are equal to each other, so they're put in the same linked list. And then in the end, you're returning a linked list of all of these linked lists. Cool. So now let's look at the structure and see, first off, like what kind of hints we can get towards how we should approach this problem. So the first hint is that since we're caring about like analyzing the digits of n, not n as a whole, we really want to use like the modulo operator, right? Because remember, whenever we're doing like digit manipulation, an easy way to get the last digit is just to take n mod 10 equals last digit. And then you can get to the second last digit by doing like n for div 10 and then take that mod 10. And you can do that so on until you get to the first digit of n. So this is another hint that we're probably going to approach this sort of backwards, because whenever we do digit manipulation, it's always easy to get the last digit, but it's kind of hard to get to the first digit. So this is kind of also supported by our while statement here, because look at our condition is while n. So essentially we're going to stop when n equals 0, because n is, or 0 is a falsy value in Python. So if you think about how we can increment n, well, we can divide, we can, my pen stopped working. Okay, as I was saying, you can floor divide n by 10 and repeatedly do that, right? N divided by 10, n divided by 10, until you get to n equals 0. And then we're going to hit our while condition and we're going to get out of the while loop. So just remember, whenever we have a while loop, we should always be incrementing somehow in order to get closer to our stopping condition. So here, since we're doing bit manipulation, I'm just going to guess that we're probably going to have to set n equal to n for 10. Okay, so where do we put this? Well, it's probably going to be, we're going to have to do this in every iteration of our while loop. So let's look at a blank that occurs in every iteration, which is right here, e. So for now, I'm just going to put that e is going to be equal to n equals n for 10, and that will get us closer to our stopping condition of our while loop with each iteration. Cool. So now, what about the rest of the structure? So we have an if-else statement, which tells us, well, are there two conditions that we have to worry about in our problem? Yes, there are, because we can either put a digit inside an existing linked list, or we can put it in a new linked list if it doesn't satisfy our grouped function. So which one corresponds to what, right? Is this going to be new linked list? Or is this going to be new linked list? Or is this going to be like same linked list? And the way you can kind of figure this out is, first of all, you can look at this condition where if part is linked.empty. Well, if part is going to be linked.empty, does it make sense to separate linked.empty and a new list? Or does it make sense to kind of group them together? Well, I'll argue that it makes sense to group them together because link.empty and a linked list is still going to be just that linked list. I know that's kind of like not a super great reason. So it's totally valid to like first try that this is going to be a new linked list, which is actually wrong. This should be like the same linked list. And then figure out that, oh, we actually need two blanks in order to do that. So then we realize that, oh, okay, that means the else case has to be the case where you have a new linked list. So yeah, since we can kind of make the argument that if part is linked.empty, we should be in the same linked list, I'll just label the if cases as such for now. So same linked list, and this is going to be new linked list. Okay. And something I haven't really talked about yet is what is part and parts. Well, at the very beginning, we've initialized them both to be linked.empty, but we know they're probably going to be some sort of important information that we're going to have to store in order to solve our problem. So let's think about what information do we want to store? Well, we need to know the current state of our linked list, of our singular linked list. So back to our first doc test, if we were building this up right to left, we would want to know, like for example, if we're looking at right here, we would want to know that our current linked list is going to be 1, 4. And then when we add another 4, it's going to look like this. So one thing we need to keep track of is our current linked list. And then when we move on to some point in the code like right here, so that means that we must have built up a linked list of linked lists that includes like 3, 3, 3, and then a 4, 4. So now we're looking at 2, so this is going to be a new linked list. So this is something that we need to keep track of, but we also need to keep track of the rest of the linked list that we've built up so far, right? So there's two main things that we need to keep track of. One is the current linked list that we're looking at, and 2 is the rest of the linked list of linked lists that we've already built up. Okay, so now we have two things we need to keep track of, and we have two different variables that they defined. So we're probably going to be able to match one to another. And to figure out which one's which, well, we can just look at the names. Hopefully that, or we can like hope that they haven't given us like kind of misleading names. So part tells us that it's probably going to be the singular linked list that we're looking at, and parts is probably going to be the linked list of linked lists that we've built up thus far. Okay, so now with all of this information, we know that the first if, or like the if block is going to be the case where we're adding to the same linked list, and the else block is going to be the case where we're adding to a new linked list. And we know that part is going to be the current linked list that we're looking at, and parts is going to be the linked list of linked lists that we've built up thus far. Let's see if we can fill in some lines of code. So our condition, if part is linked.empty, or some condition, which is when we should add to the same linked list. So when do we add to the same linked list? Well, it's when grouped of A and B returns a true value. So this means that we should call grouped. Now, what do we call it on? Well, we want to call it on the last digit of n so far, so n mod 10, and the first element of part, so part dot first. And the reason for that is because if you look at, again, going back to our classic doc test, 3, 3, 4, 4, 4, or 4, 4. So for example, if we're looking maybe right here, so that means if we're looking at here, part is going to be just this linked list, 4. And then n mod 10 is going to be this 4. So n mod 10 is this, and then part dot first is this. Right? Does it make sense why we're looking at part dot first, not part dot rest? Because we're building up our linked list from right to left. So in order to get the element that's right next to n mod 10, we actually have to look at the first element of part. So I guess it'd be more clear if you looked at the example with the 3s. So like, for For example, if you're looking at right here, we're analyzing this element, that means part is currently going to be 2 3s because we've already analyzed these two. Then we want to compare it to the left 3, right? So we want to get part dot first and compare that is going to be B and n mod 10 is going to be our A essentially. Okay, so hopefully that makes sense why we call grouped on n mod 10 and part dot first. So if we have that case, what do we do? Well, we're going to have to update part, right? Because part we already established to be the current linked list that we're working on. So if we want to add the kind of nmod 10 to current part, then we want to basically move this 3 into here. So in order to do that, we have to set part equal to part has to be a new linked list containing nmod 10 and part, because we want to insert this nmod 10 to the front of the linked list. Okay, cool. So now moving on to the else case. So this is a case where we don't want to add it to the existing linked list. We want to kind of break it into a new linked list. So what do we need to do if we want to do that? If we want to break our linked list into a new linked list, we need to save what we have so far. So for example, now let's say we're looking at, let's erase this stuff. So now instead of this 3, we're looking at this 2. So in this case, we want to have, so far part is going to be this, but we want to make part now a new linked list that contains just this 2, right? Because 2 is not equal to 3, so we don't satisfy our grouped function. So in order to do this, we have to first save this part, right? Because we want to keep track of all the parts that we built up so far. So we're going to have parts kind of take on this part. So the way you do this is you have parts equals new linked list containing part and what it had so far, which is parts. So that saves our part into parts. Okay, and then what we want to do in order to update part is just to set part equal to link of nmod 10, because that's our 2. So we want part to now equals a linked list of 2. Okay. Whew. Alright, so now finally, what do we return? Now it's really tempting to just say parts, right? Because parts theoretically should contain all of the, I guess, parts that we've built up into a linked list of linked lists. But the problem with this is in our very last case, where now, for example, we're looking at right here, we haven't actually added 3 into parts yet, right? Part 3 is still just inside part, not inside parts. So in the end, when we finally get to like the end of our while loop, we need to include what is inside part so far, or like at the moment. So what we really need to return is a new linked list containing part and parts, which is what we've built up. Cool. So again, as a sanity check, let's move this stuff we wrote into the blanks. So grouped nmod 10 part dot first. B should be part equals link of nmod 10 and part equals link of nmod 10 part. Yep. C should be parts equals link of part and parts equal link of part and parts. Nice, we have an option here. D should be a linked list of nmod 10. Perfect. E is something we fill in, so we filled in that. And F again is something we fill in, so it's just a link of part, comma parts. Cool. And just like a quick note, the kind of neat thing about digit manipulation and linked lists is they both kind of naturally happen backwards, right? So digit manipulation, it's really easy to work backwards because you can get the last digit and then get the second to last digit and get the third to last digit, blah, 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 using the modulus operation. And similarly, when you build up linked lists, it's really easy to add to the front of a linked list because you could just have, like, for example, if S is a linked list, you can add to S by just saying S equals link of new L and S so far. So like if S looked like this, in order to append a 0, well, you just make a new linked list that contains 0, and then the rest of that new linked list would point to our old linked list. Yeah, sorry, the drawing got cut off, but that's kind of why it's really natural to have bit manipulation or digit manipulation and building up linked lists in the same problem, because since they both happen backwards, in the end you get the linked list in the correct order, which is why when you run all this code, eventually you will get this answer in the right order. Even though we work backwards, it'll still be in like the 3, 2, 3, 3, 3, 4, 4 order. So yeah, hopefully that made sense, and I'll move on to the next problem.